Okay, so now that we know how to find critical numbers, we're going to find how do I use critical numbers to find out if they're a maximum or minimum. And that's done using the first derivative test. So, if it's a first derivative test, it kind of helps guide you with saying we have to take a look at the first derivative. So let's see what are the different options we can see. And so it says, test the intervals between critical numbers to determine if f prime of x is positive or negative. So anytime we looked at our previous graph, and anytime I have something that is increasing, what did you notice about the derivative? Well, I'm hoping you said that from before, we noticed that the derivative had to be positive or greater than 0. Right? Well, if something was decreasing then, what do you notice about its derivative? Then if this one is greater than 0, then anything decreasing had a derivative that's less than 0. So when taking a look at that, it's going to help us find our maximum and minimums. And if it says if the derivative changes from positive to negative at a critical number, that means my derivative is increasing to decreasing. What do you think we have at this point? Good, this is a maximum. I'm going to try to write neatly here. And so on the other end, if I have a derivative that goes from negative to positive, so let's draw this out right here. It's decreasing to increasing. What do you notice about this point right here? That I'm going to have a minimum. So this is the verbiage behind the first derivative test, but we actually have to put this into practice. So let's take a look at some problems and see how we can find whether or not I have a maximum or a minimum. So our first problem here, it says find where it's increasing and decreasing, find the coordinates of all relative maxima, and identify as a maximum or minimum. So in order to do this first part right here, where I'm increasing or decreasing, what I need to do is find the critical points. So let's write this out in steps. So first I need to find increasing, decreasing. I also need to find coordinates, and I also need to tell you if it's a maximum or minimum. So step 1 is to find the critical numbers. And that's by taking the derivative, setting it equal to 0. Step number 2 is observe these by using test points. So I'll show you what that is. Use test points. And then right here, we're going to need find the x and y values. And then finally, determine if it's a max or a min. So these are the steps that we're going to be doing. And they're not specifically a 1, 2, 3, 4 step, but these are the main points that we're going to need to do. So what I'm going to do is I'm going to erase this section just so, excuse me, just so I have some room. Okay. So first step was to find the critical points. And just like our previous lecture, the critical points are when I set the derivative equal to 0. So first let's find the derivative. I get f prime of x is equal to 4x cubed minus 16x. To set this equal to 0, let's factor. So I pull out a 4x and then get x squared minus 4. And I can factor this some more into x plus 2 and x minus 2, right? So let's go ahead and set these equal to 0. So I have 1, 1, 1. So 4x is equal to 0, that means x is equal to 0. X plus 2 is equal to 0, that means x is equal to negative 2. And x minus 2 is equal to 0, and that means x is equal to positive 2. So I have 3 critical points here. And what I'm going to need to do is find out if these were increasing or decreasing. So what I'm going to do is use a number line to draw these out in order. So let me make sure I have the right line. Oh no, that's not the right one. Well, let's fix that. Alright, so let's go back to this. Extend this page. Alright. So I'm going to move this over. And we're going to create this number line. So I'm going to break it up into my 3 critical numbers. And those critical numbers I'm going to put in order. So I know this one is negative 2, 0, and positive 2. And what I know is these are my x coordinates. What I do know is what I know about the derivatives. So I know this derivative is equal to 0, this one's equal to 0, and this one is also equal to 0. And so what I'm going to do is I'm going to find out what is happening at these derivatives. Okay, so let's pick a couple test points. So let's pick negative 3, which is less than negative 2. A number between negative 2 and 0 is negative 1. Between 0 and 2 is 1. And a number bigger than 2 is 3. So what I'm going to do is plug these into the derivative to find out if these are positive or negative. And so if I take a look at these, right, I have this derivative right here. And let's just take a look at the sign values of these things, okay? If I plug in negative 3, what I'm going to end up getting is negative 12. So I have a negative. Negative 3 plus 2 is also a negative number. And negative 3 minus 2 is also a negative number. 3 negatives are going to give me negative values, right? So what I know is right over here, negative 3 will always give me, or in this region, I'm always going to have a negative slope of a curve or negative derivative. And so, let me just move this down here. I'm going to do this again for negative 1. Well, if I do this with negative 1, negative 1 times 4 is negative. Negative 1 plus 2 is positive. Negative 1 times minus 2 is negative. So 2 negatives and a positive will give me a positive value. So I know in this section, it's always going to be positive derivatives. Let's do this for positive 1 now. This is going to give me a positive value. This is going to give me a positive value. And this is going to give me a negative value. So if I multiply all of these, I'm going to see that I always get a negative derivative. And if I plug in positive 3, I'm going to get a positive times a positive times a positive, which will always give me positive intervals. So all I'm doing is picking test values right here to see what's supposed to happen to my derivatives. And if I were to take a look at this, negative derivatives tell me I'm decreasing. Positive derivatives tell me I'm increasing. negative derivatives tell me I'm decreasing, and positive derivatives tell me I'm increasing. So if I take a look at this, what's happening at this point right here, this point right here, and this point right here? Good. So these points right here are minimums, whereas this point right here is a maximum. So I have two maximums and two minimums and one maximum. And if I read the directions, it says I need to find the coordinates of these. So I have the x values. What I need to do now is find the y values. So if I find my y values, I need f of -2, and that is equal to -2 to the 4th minus 8 times -2 squared plus 1. 16 minus 32 plus 1 is equal to -16 plus 1, so -15. So this x value is -2 comma -15. And this is one of my minimums. My other minimum is when f of +2 is the value, and so I get 2 to the 4th minus 8 times 4 plus 1. That also gives me 16 minus 32 plus 1. And so my other minimum value is at +2 comma -15. That's my second minimum. Let's go ahead and find my maximum value. Well, the maximum value is when x is equal to 0. So f of 0 is equal to 0 minus 0 plus 1, which gives me a maximum value at 0, 1. And the last part of this is to find out my intervals of increasing and decreasing. So what I'm going to do is go back over here. Let me scroll all the way down and find out what's happening. Well, if these were negative, that means I'm decreasing in this section right here, right? There's my barrier. In this section, I'm all positive, which means I'm increasing. So there's my barrier. Right here, I'm decreasing again because I'm negative. And right here, I'm increasing again because I'm positive. So to write this correctly, we have to write the intervals. So I am decreasing from -infinity to this x value of -2. And I'm also decreasing from this section right here, which is 0 to 2. And then I'm increasing in this section, which is -2 to 0. And then I'm also increasing from +2 to infinity. So now I've answered all questions. The increasing and decreasing intervals, as well as the coordinates of extrema, and telling me if it's a maximum or minimum. So what I'd like you to do is try the next two problems, and in the next video you'll see the solution to those problems. Good luck!